How do pressure sensors use an ADC? Imagine trying to measure how hard the air pushes against a surface or how much liquid is pressing on a pipe. Pressure sensors help us do that. But how do they turn these physical forces into something a microcontroller can understand? That's where an analog-to-digital converter, or ADC, comes into play. Pressure sensors usually give out an electrical signal that changes with pressure. This signal can be a small voltage, a tiny current, or a change in resistance. For example, some sensors produce a voltage from a few millivolts to a few volts, depending on the pressure. But microcontrollers and digital systems only understand numbers, not voltages or currents. So, we need to convert that analog signal into a digital from that the system can process. Before the ADC can do its job, the sensor's output often needs some adjustment. Signal conditioning circuits, using operational amplifiers, boost or scale the signal so it fits within the ADC's input range. For example, if the sensor outputs a voltage from 0 to 1 volt, but the ADC accepts 0 to 3.3 volts, the circuit will amplify the signal to match that range. This ensures the maximum pressure reading uses the full resolution of the ADC. Once the signal is conditioned, it is fed into the ADC. The ADC samples the voltage at specific intervals, like taking quick snapshots of the signal many times per second. It then converts each snapshot into a digital number. The resolution of the ADC, such as 10, 12, or 24 bits, determines how many different digital levels it can produce. Higher resolution means more precise pressure measurements. After the ADC converts the analog voltage into a digital number, the microcontroller or digital processor takes over. It reads the number and uses formulas or calibration data to translate it into real pressure units like pounds per square inch, bars, or pascals. This step accounts for sensor inaccuracies, offsets, and nonlinearities, making the measurement more accurate. In real-world applications, pressure sensors with ADCs are everywhere. They monitor fluid pressure in cars, industrial machines, or aircraft systems. For instance, a sensor might output a current signal from 4 to 20 milliamps. An ADC can't read current directly, so a resistor converts that current into a voltage. The voltage then passes through the signal conditioning circuit, gets sampled by the ADC, and finally, the microcontroller calculates the actual pressure from the digital data. So, in simple terms, pressure sensors use an ADC by first turning pressure into an electrical signal, adjusting that signal to fit the ADC's input range, converting it into a digital number, and then processing that number to find the pressure. This process allows embedded systems to accurately monitor and control pressure in countless devices and systems.